Hi everyone, welcome to the first video of our new outline, Handling Outliers. So let's see the agenda of today's lecture. First of all, we will learn about what is actually an outlier, and then we will see the methods by which we can detect outliers. So outlier refers to these data points that are significantly different from the other data points in a given data set. These data points may be much smaller or larger than the other data points, or they may be far away from the central tendency of the data, which means that these are the strange data points or observations in the data set that are not normal. Now, here's the question that why there are outliers. Outliers can occur inside the dataset for various reasons. They may be due to errors in data collection, or they can also be a genuine or a natural cause of the phenomenon being studied. Let's say we have a shop of burgers and we have an event in the whole country. So on that holiday, people are most likely to buy more and more burgers, so that they may contain outliers. So this is a natural phenomenon. Now, outliers can also be caused by extreme values in the population being studied or measurement errors. So do they have an effect on our analysis or modeling? Yes, outliers can have a significant impact on statistical analysis in R. They can distort the mean and standard deviation of the data, and they can also affect the results of hypothesis testing and regression analysis. In some cases, outliers may even make it difficult to draw meaningful conclusions from a dataset. So let's say you have an array of values 1, 2, 3, and 5. So let's say you have an array or list of 1, 2, and 100. Now, if you try to find out the mean, then the mean value will be distorted because of the outlier that is 100. Now, let's say you have an array of 3 elements, 1, 2, and 40. So the mean will be distorted because of this outlier that is 40. And that is why we have to deal and handle carefully our outliers that are present in the dataset. So now let's move forward. Should we delete them? No. In R, there are various methods to deal with outliers. Sometimes they may contain important information, and sometimes they're just the random or the strange observations in the dataset that are the result of mistakes or errors. So we have to carefully deal with them. One approach is to identify and remove them from the dataset. However, this should be done with caution, as outliers may have important information like I mentioned earlier. In some cases, removing outliers can improve the accuracy of statistical analysis, while in other cases, it can lead to biased results. So, what are the techniques for outlier detection, or how to detect them? Detecting and handling outliers in R can be done using various methods. Here are some commonly used techniques. First, we have box plots. Box plots can be used to identify outliers visually. The points that fall outside the whiskers of the box plot are considered outliers, and we will see its practical implication in this video. Next, we have Turkey's method. Turkey's method is a statistical technique that utilizes quartiles for detecting outliers. After computing the quartiles and interquartile range, the method identifies outliers as any data point that fall outside of 1.5 times the IQR. So now let's move to our study to see how it works. First of all, let's read our dataset with the help of read.csv function, and here I will pass the name of CSV file, and then I say head cars. All right, So you can see the column names of your dataset. So before detecting the outliers, I will just clean the dataset a little bit. First of all, I will say cars and na.omit to omit all of the nowheres from the cars dataset. All right. And here I will just say cars, and I will use the gsub function to just make all of the column names into lowercase and replace the dot inside the column names with the underscore. So I will first say replace this with an underscore and two lowercase, and I will pass the call names of cars. And also here I use the call names function. All right, here I forgot to put the s, and here as well. And now let's say head cars. Now you can see the dataset is visually appealing. So now I will load the library of ggplot to use the box plots in order to identify outliers. And here I will say outliers 1. And inside this variable, I use the ggplot function. I pass the dataset, that is cars, and then I use the geombox plot function. And here I use the static function. I say take the cars dataset variable of vehicle size on x-axis and y equals to take the cars dataset variable of popularity, and next I say outlier dot color equals to red, and here I pass another function which is ggtitle, and the title of my box plot would be box plot outliers. All right, and in the last I will also pass the labels. I will say labs and x equals to vehicle size and y equals to popularity. And in the last, I just say outliers 1. Now let's run it. Now you can see a beautiful box plot with vehicle size versus popularity here. And the points that you see here are the outliers because they fall outside the whisker. As I mentioned in the previous videos, this line represents the median, and this is the third quartile, and this is the first quartile. So any point outside this whisker or these quartiles will be an outlier, as you can see above here. Let's take another example. I will say outliers 2, and I will use the ggplot function. I say take the dataset of cars, and here I use the static function, x equals to cars, and I pass the vehicle size on x-axis, and on y-axis I say take the cars dataset and the variable of engine horsepower. And next I say geom box plot and outlier dot color, and I pass the color red, and next I say labs, and the X label should be vehicle size, and Y label should be horsepower. And last but not least, I will say ggtitle, box plot, outliers of vehicle size and horsepower. And here I say outliers 2. Now you can see a lot of outliers in vehicle size compared to engine horsepower. And all of these red points are the outliers, as I have given the color red to these outliers. You can see that the compact size has all of the engine horsepower above than 450 outliers. So you have learned how to identify or detect outliers using the box plot. Now let's try the next method, which is by using the interquartile range. So let's do it. Now, first of all, I will calculate the quantiles. I'll say quantile, and here I will pass the name of my feature or column. I'll say engine horsepower and 0.25, which is going to be my first quantile, and the third quartile will be quantile cars and engine horsepower, and then 0.75. All right, so here I'm going to find out the IQR or interquartile range, which is going to be Q3 minus Q1. And next, I will calculate the lower and upper bound. For lower bound, I will say 1.5 times IQR, but I will first say Q1 minus. And for the upper bound, I will say Q3 plus 1.5 times IQR. So I have so far found out my quantile, then interquartile range, then lower and upper bound. And now what I will do is that I'll say take the car's data set and the variable of engine horsepower, and inside the data set, just take the car's data set engine horsepower values that are greater than lower bound and the car's dataset engine horsepower values that are smaller than upper bound. And then I will store them in my outliers variable. And in the last, I will just say cat, and I will say outliers are. And here I will print all of the values that are outliers in my engine horsepower. All right. Oh, here I forgot to just put the signs in the right direction and greater than upper bound. All right, now let's run it. The values that you see here are the outliers in engine horsepower, and these are the different values. You can see them here. All right. Now, for instance, I want to say that I want to calculate all of the outliers in my numerical columns. So, and then put them in the outlier list or something like that. So, in order to do that, library, and here I use the library dplyr, and then I just simply create a list of columns in which I store my variables for whom I want to calculate the outliers, including engine, horsepower, and highway, MPG, city, MPG, popularity, and MSRP. All right, and here I create outliers tree vector, because I'm going to store all of the outliers in this vector. So here, let's just create a for loop. I will say for column in columns. And inside that, I will repeat the same above procedure. But first, I will just simply say call data equals to cars and call. All right. Now here, I will calculate the keyword by just simply saying quantile. And here I will pass the call data and I say 0.25. And similarly, I will say Q3 quantile to find out the third quartile and 0.75 and IQR equals to Q3 minus Q1. And here I say lower bound. And inside the lower bound, I just simply say Q1 minus 1.5 times IQR. And for the upper bound, I say Q3 plus 1.5 times IQR. And in the last, I just say outliers free, and inside this, I use the combine function because I'm going to combine all of the outliers. I say outliers free, and I say take the call data, and inside the call data greater than lower bound or call data smaller than upper bound. And in the last, I just say cat and I say outliers list is, and here I say outliers free. And just don't forget to put an extra line. Now let's run it. Great, so you can see a list of all the outliers for these above columns that you have mentioned in the column section. Now let's get back to slides. So in today's lecture, you have learned how to detect outliers using the box plot function and also with the help of technique of IQR. So now your homework is to detect the outliers using both methods. And here is the link of red wine quality dataset. Now good luck. See you next time.